We're going to continue looking at different conditional statements in lesson 17. We have in the past already covered conditional and converse statements. Conditional means if P, then Q. Converse is the reciprocal of that. If Q, then P. So if we have a statement such as if Sylvester walks to work, then it is a Wednesday. That would be our conditional statement. Converse would be if it is a Wednesday, then Sylvester walks to work. That's what we've had in the past. The next thing we're going to cover is what is known as a negation. Now, the symbol for negation is just a little squiggly line. And that is called not P. So if I have something like the negation of P, that would be not P, is how you would read that. So if I had the statement, example 2 says, if a pentagon is regular, then it is equiangular. It's equiangular. Okay? That is our conditional statement. If it asks us to write the negation of each statement, well, the negation of this statement would be if a pentagon is not, there's a key word, regular. That would be your negation, your not P. You would say then it is not equiangular. So there would be your not Q, and that's all a negation is. We have two more statements that we can make using the negation sign. One is the inverse. And it all roots back to the conditional, but if you have a conditional P then Q, inverse is if not P, then not Q. So this is the conditional statement. If a pentagon is regular, then it is equiangular. The converse of that would be if a pentagon is equiangular, then it is regular. That would actually be false. The inverse statement would be what we have here. If a pentagon is not regular, then it is not equiangular, and that would be a true statement. The last statement we have that we'll go over is contrapositive. Contrapositive means if not Q, then not P. So we've covered all angles here with the P's and Q's. So if I was to make this statement contrapositive, I would say if a pentagon is not equiangular, then it is not regular. So I would simply switch the regular and equiangular is all I would do. And that's all contrapositive and inverse statements are. So problems may ask you to write the conditional statement, and then it may ask you to word it in the contrapositive or inverse format, and you would just have to do that, and then it may ask you, is this true or not, and you would have to decide that. So that's lesson 17. Let's move on to lesson 18. Looking at some algebra within the triangles. I want to start with the triangle sum theorem. You've probably learned this before, but the triangle sum theorem, let's move it this way. Triangle sum theorem is simply, okay, here's your triangle. The sum of all three angles equals 180 degrees. So the measure of angle 1, plus the measure of angle 2 and angle 3 equals 180 degrees. So in example 2, you have triangle DEF, and it wants us to find angle D. It gives us E is 58, D is a right angle, therefore it is 90 degrees. So what would angle D be? Well, we know that they are all adding up to be 180 degrees. So we could say 58 plus 90 plus angle D equals 180. And then you would solve. So 58 and 98 would be 148. And you would subtract and find that angle D is 32 degrees. But that's just using the triangle sum theorem. That's all that is. In example 2b, it says in right triangle KLM, angle K and L are congruent. Determine angle K. Well, what I like to do in these cases is draw out the triangle. I'm visual, so I like to draw it out. So I have a right triangle. I know that. I have a right triangle. It doesn't necessarily tell me which angle is the right triangle angle. However, it does tell me angle K and L are congruent. So let's see. Angle K and L are congruent. Let me make sure I'm not missing anything. Okay. So here's K and L. We know M is the right angle because it's 90 degrees, and that's not going to be able to be congruent with anything else. So if it's congruent, we know that both of these angles are actually going to be complementary. We could say angle M is 90, then plus angle K plus angle L equals 180. Now what we can do here is what's called substitution. Since we know that they are congruent, we can actually refer to angle L as angle K. So now we have two of the same variable. Just like adding one x plus another x is adding angle K plus angle K, we can call that angle 2K. And that equals 180. And now we can solve. So subtract 90. 90 equals 2K. Divide by 2. Angle K would equal 45 degrees. And once again, that's just using the triangle sum theorem and a couple other parts that we know about triangles. Last part we're going to look at here is the exterior angles theorem. Exterior angles theorem is at the top of page 111. Okay. Exterior angles theorem. Imagine we have a triangle here, and it has a line that is going exterior. All this is we are saying angle DCA equals the sum of angle A plus angle B. Angle A plus angle B. So to look at that here, say we're looking for angle WYZ, so we're looking for, I'll put an arrow, we're looking for that angle. All we have to do is add these two sides together, 70 plus 50, get 120, and that would be the measurement of angle WYZ. So that's all the exterior angles theorem is. It gives us one other example. It tries to trick you a little bit. It gives you 32 degrees, and then it gives you the exterior angle. So it's working. All this one is working backwards. So we have 48 degrees, 32. Well, let's go ahead and plug in what we know. We know that 48 degrees would equal the sum of, let's see the letters of this triangle, QRS. 48 would equal the sum of angle Q and angle P. So angle P plus angle Q, we know that's 32, would equal 48. So we solve for that, subtract both sides. You solve, oh, don't know why I did that. You solve and you get 16 degrees for angle P, and that would be your answer. And that's all there is to the exterior angles theorem. So just a couple easy math concepts with the triangle sum theorem and exterior angle theorem for triangle algebra. And that concludes lesson 18.